Now this tidbit of anatomical and physiological information can help us teach exercise, it can help us program exercise, and it can help us provide wise customer advice. Now think of all the calf exercise gimmicks out there proposing that they improve vertical jump or sprint speed. Now think of the multi-headed gastrocnemius muscle, that's the big one on the back of the calf. It has muscle fibers that are pinnate to its tendon. Now you should already be familiar with that tendon, the Achilles tendon. And as such, because of that pinnate structure, it's biased to produce force, not velocity. So when you think about it, you can't jump slow. And putting those pieces of information together, that means that the anatomical structure of the gastrocnemius precludes a large contribution to getting some hang time up in a jump. When we add the slower contracting fiber type profile of the gastrocnemius and the mechanical leverage disadvantage, we have a further limit to the contribution of the gastrocnemius to jump height. We get off the ground not because of the gastrocnemius and coming up on our toes. We get off the ground because the hip and the knee extensors are built to get us up into the air fast. The calves contribute at best a couple percent to the total height. This means spending a great deal of training attention to, or lots of money on, the gastrocs for the intent of increasing jumping performance is likely time misspent and money wasted. When we're in a professional fitness practice, a conceptual understanding of the anatomy of muscle contraction is absolutely needed. Such an understanding makes it obvious that there is a lot going on within a muscle during contraction. And there is a lot going on, from individual molecules to the entire muscle. Muscle anatomy forms a structural basis of contraction. From the proteins that produce the force to the level of whole muscle action, a simple understanding of how things are built forms the core of our knowledge of how to change their structure and to improve their function. The physiological processes that induce and support muscle contraction are numerous, diverse, and they're absolutely important to know.